I have great pleasure to invite Mr. Marius Shuster from Stuttgart, Germany, to present a plenary paper named New Pathways to the Hydrogen Society. You're welcome.
Yeah, no problem. Good morning. You will understand my presentation in English because unfortunately I cannot speak Serbian. And I just arrived yesterday from Bucharest, where I was also holding the same presentation which you will see in a moment. This presentation is about the new technology which you see here in the first line, which is about FCH. And FCH stands for fuel cell and hydrogen. And this is one domain of 8 in total, as you see here, which are defined by the so-called SET plan, which stands for the Strategic Energy Technology Plan, the European one. And one domain is dedicated especially to the fuel cell and hydrogen domain. And these technologies are in a unique position from all of the others that they can be applied, what you see above, in the energy domain as well as in the transport domain. And this is what I will talk about, and I will show you some examples about this, because they are different to the conventional technologies. Why do we need these technologies? Of course, like everything, nothing is new. We did not invent something new, but we perfectionized something. These technologies were applied by NASA in the space. There were since 20 years fuel cells for producing energy. Now we make use of these technologies for storing big energy capacity, yeah, like in terms of gigawatt. We know other technologies like batteries, supercapacitor. I think we will hear also something about this. What you see here, that the supercapacitor can store a lot of power, but for a short time. So we need to use this supercapacitor. And now, because we see here many technologies, yeah, I remember some words from which I heard from Mr. Amory Loving. Some of you may heard about him, some not. He was distinguished with the Bundesverdienstkreuz in Berlin, and he said about all the technology, there is no perfect technology. Any technology is like, makes her own tone, but all together they make nice music. So it means we need all of this technology. We have application for supercapacitors, and we have application for hydrogen and fuel cell. And I would like to show some of this, like in the following slides. We all talk about renewables. Yeah. Okay. You cannot see the. Okay. Yeah. Is there a pointer here? Yeah.
No, probably a mistake. I'm sorry.
Okay. Somebody will.
English
I press the red button. Do you have a laser point? Okay, no problem. No problem.
Yes, but there's no buttons. Yes, yes.
So, talking about this new technology, the problem is of storing. We have renewables like wind plant generator. Yeah? We have photovoltaics. Now the problem is that these generate power depending when the wind is blowing, or whether the sun is shining or not. That's not quite actually the time when I need the energy. So, if many people insert this energy into the grid, it makes fluctuating the grid depending on the weather. We don't want this. So a solution would be to store it in a hydrogen for a long time. And then we have different applications for using it in the mobility. Thank you very much. And when I'm talking about mobility here, I'm talking about electromobility. Just two words. Some of you may have heard about Tesla, about the car Tesla. The innovation of that car is putting as many batteries as you can in a car. Computer batteries. The other possibility is power it by hydrogen and fuel cell. So a fuel cell is like a battery which produces electrical current when you insert hydrogen in combination with oxygen from the air. That's all. So in this case, talking about fuel cell and hydrogen, we talk about electromobility. This is a small principle. We generate electricity by electrolysis. So there is a way of generating in the green mode, in the green manner, using energy from wind power, from solar power. We can convert it into hydrogen, store it, and the reverse reaction is using it. This is a fuel cell, a simplified drawing where we insert the hydrogen. We have the oxygen from the air, which we just breathe now, and on the exhaust pipe we just get water again. So there's a whole green circle. And I invited Professor Stevic and also Ilya and some of you. We've been in Germany to Energiepark Mainz, where we have the biggest plant in the world of producing hydrogen from renewable sources. This is a vision of what we can do. So we have the renewables here, we can convert it, we can use it, we can store it, we can insert it directly into the methane gas grid, and so on. So there are different applications, like in the buses here, in forklifts, even bikes, ships, and so on. Yeah. And here, only one thing I want to mention. Why? Why do we not see, if these technologies are so good, why don't we see them on the road already? The problem is the infrastructure, or as we call it, the chicken and egg dilemma. Chicken and egg dilemma means, if I want to see electromobility on the road, we need a fuel station. We need to fuel this. Yeah? So as a fuel station costs 500,000 euro, the provider asked me, where are the cars? So this is the chicken and egg. And we start solving this problem in Germany by starting using them in buses. As soon as a fleet of 20 buses can use one station already. So then it's already economical. At the moment we have 30 stations in Germany. At the end of the year or next year 50. By 2023 we will have 400 stations and so on. This is a picture of the actual, and you remember where we've been here. I think there was also an article in a newspaper. Thank you very much about this. Yeah, in Serbian. Yeah. And don't like to spend too much words because I have only short time. So this exists as a cooperation. Lindegas, Siemens, the government, the universities, also very important, because this technology have reached already the so-called TRL, which stands for Technology Readiness Level of 6, 7, 8 and higher, which means they are ready for market deployment, but there is potential for research to make them more efficient, to substitute expensive metals like platinum. Yeah, so there is potential. They depend, if I want to produce hydrogen, so they are expensive at the beginning, but depending on the electrical current price, they can get cheaper. Now, why I put these two slides here is because every time I talk about the hydrogen, people are afraid that I'm talking about a bomb with hydrogen, which is not the case. So, in Germany, we even shoot on the car with hydrogen. Nothing happens. They do not explode. Cars do not explode like in movies. They explode only in movies, but not in real life. Now here we intentionally made one. We set fire here. This is a conventional car. This is a hydrogen car. We intentionally set fire. We intentionally punch them, shoot on them. And as you see here, there is a stitch flame, which you usually, actually, the hydrogen burns as you don't see it. But here, there are some materials will come here, and these materials burn. And here the fire also started. And what you see is on the second slide, the stitch flame gets smaller and smaller, as in a few seconds, in 1 minute, the whole the gas is blown out. And this is what happens with the conventional car. So, I don't want to say it's not dangerous. Of course, we should take care how we handle the methane gas and the hydrogen. So hydrogen alone does not ignite. We need the hydrogen. Only the combination with hydrogen and oxygen. Oxygen, yes, oxygen explodes or ignites. Some application for hydrogen in the industry, in the electrical domain, in the electromobility domain. Maybe one which is interested for you, the so-called CHP, combined heat and power. You usually know this with conventional, with the motor. A motor, combustion engine that drives a generator, and then you have co-generator. Maybe also heat and power, using heat and from the... Here, nothing is revolving. Inside, there is a fuel cell. We directly can connect it to the methane gas. I can bring one tomorrow here and install it in this building for generating the current for all these lights and also the heat and so on. This is the same principle here, but what I want to show you that we reach here an efficiency, an energy efficiency above 90%, even more, 95%. That's usually, this is the lowest efficiency, which no other technology at the moment can provide such high energy efficiency. Why don't we have this here? Because they are expensive, like the iPhone, like the cell phone. So in Germany, we want to show you, teach you about this technology, and we want to spread them. As more as we spread them, they got cheaper. And when we sat with Dr. Shepard at the table, we were thinking all with your brilliant ideas, and we were thinking about the strategy of introducing you on the Danube, yeah, to all the riparian states, because in the European program, the Interreg Danube, there are 14 countries, which Serbia can also join. Yeah? So it's also a unique possibility for you, and the way we join it is by buses here. Now, as Serbia has only the transportation, you don't have a metro, you have buses, the only bus. This is very important for you. As we started, just as an idea, a bus costs 650,000 euro or 1 million euro for the 20 meter. This is also too much money for Germany, but there are ways, yeah? And we will show why. Now, only to keep about trucks or buses. Trucks or buses. This is a comparison of a truck, could be also a bus, with hydrogen and fuel cell. And this is the amount of batteries that you have to carry with you to power this bus. Yeah? So, you see, you don't want to carry batteries with you, you want to carry people. The other thing is, how long time do I need to charge these batteries? When I was at GSP, they have buses with supercapacitor. They are pleased with them for short and going. Eh? But they say, Mr. Shuster, our buses are running 23 hours of 24. There is no time to charge this bus with battery. But refueling by hydrogen takes 5 minutes. Takes exactly as you know it is LPG or gas, so there is no change in people's mind. You just go to the station, fuel as you are used to, and drive electrical. What we want to do is to create a so-called hydrogen society with this principle, using different programs, Horizon 2020, FCHGU, and so on. I will try to make it short, maybe only the last slide, or I have some more, but I try to make it short. This is the application possibility. I want you to look at this slide from two perspectives. One perspective is the pipe here, that it's a pipe with hydrogen, which we want to make, and then we can generate hydrogen, actually from everything, from coal, yeah, from methane gas, and so on. Yeah? And can use it for mobility. But this is what we want to do on the Danube region also, to make a pipeline, and all the countries to take advantage of this technology. And for the last minutes, I would like to show you a practical demonstration. Is there still time? In the break. Okay. So I would like to stop here my presentation, and in the break I will show you a practical demonstration where we generate hydrogen and use the hydrogen, and hopefully we don't explode. No, I'm sure. Thank you very much.
Thank you very much.